Hi everyone, let's talk about a puzzle called the Knight's Tour. In this puzzle we have an 8x8 standard chessboard and we have a knight that is sitting in the bottom left corner of the board and we want to transport it to the top right corner. Now this is definitely possible and you should figure that out on your own, but the difficult part of this problem is that you want to determine whether it's possible to visit every single square along the way. So this is called the Knight's Tour. So we want to visit every square, and the bottom left is automatically visited because you're there to begin with, and you want to land in the top right in the end. So I'll give you a few seconds to think about it. You can pause the video if you want, and I'll count down from 5 and then I'll cover the solution. 5, 4, 3, 2, 1. Alright, let's take a look at the solution. The key insight is that no matter what square the knight is sitting on, the 8 positions to which it can move are all of the opposite color. So if the knight is sitting on a colored square like it is in this diagram, then the 8 squares to which it can move are all non-colored. And if it were to start on a white square, then it would move necessarily to a black square. So this is our lemma. Let's see how we can use that. If we were to have a knight's tour of the sort that we want, then there would need to be 8 squared minus 1, which is equal to 63 moves, because the bottom left is automatically visited, and there are 64 squares in total. So we subtract the bottom left to get 63 squares that we have to visit, which means you have to move 63 times. But the problem is that the parity of 63 is odd, meaning it's 1 modulo 2 in terms of fancy modular arithmetic. And that means that you have to move an odd number of times. So if you move an odd number of times and you start from a black square, which is the bottom left, then you will land on a white square in the end. And that means it's a contradiction because you want to land on the top right, which is a black square. Therefore, this tour is impossible. Thanks for watching, and I'll see you next time.